talked about this, but US is advantaged on the feedstock. What is interesting though is that future prices for LNG, which determines feedstock costs, especially in overseas markets, right, are also pretty low going forward, right? I mean, this can change obviously as we get closer to these out years, but a lot of this is predicated on the expectation that there's going to be a lot of LNG capacity that's going to come on stream. But in terms of some of these overseas chemical plants, the US is also helping them out by producing a lot of natural gas liquids which are being exported. We actually have a very bullish view of natural gas liquids production. And a lot of this is because as shale matures, the gas-oil ratio is increasing, and as gas increases, the production of lighter hydrocarbons increases, and that then is what is essentially a lot of natural gas liquids. Because of this, we are producing a lot of ethane. In fact, we could conceptually produce more ethane if ethane prices were supportive, and additional exports will be supportive of ethane prices. Right now, quite a bit of ethane continues to be rejected and used as natural gas. But we are slowly seeing the addition of ethane export capacity. We have a couple projects coming up here shortly, and that should essentially export more ethane. And a lot of this ethane goes to overseas markets in Asia, including China, which is one of the interesting dynamics that we are working with. In comparison, if you look at feedstocks for overseas chemical plants, right, most of them are pegged to crude oil because they're using naphtha as a feedstock. So you can see the price differential there that is normalized on a $1 per million BTU basis in terms of olefins production. So you can see that US is significantly advantaged, while a lot of overseas, especially Asian chemical capacity that's pegged to, let's say, crude oil is paying prices almost as much as 4x if it's naphtha, and that price is even higher for propane because there are a lot more competing options and end users for propane, therefore that price tends to be higher. So because of this, right, we expect propylene and ethylene margins to be depressed in China. But the problem that does is because there's so much capacity, a lot of that is then converted into polyolefins, which is then dumped into markets all around the world. So that's what I have. Steve, looks like you have a presentation. Maybe we'll let you go through that and introduce Chemstations and DataCore. And then, Walt, I believe you have a short presentation. Maybe we can go through that. So,
I only have one slide. It was a New Year's resolution of mine: fewer PowerPoint slides this year. So I tried to pack it all onto one. So I just want to introduce you to the business. DataCore is a highly acquisitive software company serving process manufacturers. And to think about this, what is a process manufacturer? Even some process manufacturers don't think of themselves that way, but effectively, anytime you're making something that is not discrete manufacturing, if you imagine, making forks or refrigerators, quite different business than making chemicals and materials. So DataCore was very focused, is very focused, and the thesis is to be the leading software provider for all of the challenges in the process manufacturing space. And so starting with products like enterprise resource planning, customer resource management, manufacturing execution systems, asset tracking, all the way down to tools like ChemCAD, which is a chemical process simulation tool, and AFT Fathom, for instance, a fluid flow technology. And so what you're looking at here is just kind of a spread. And my engineer brain always hates when marketing people try to collapse everything into one or two dimensions, because I can give you a half a dozen examples of where this completely breaks. Data centers have been a big topic of discussion over the last couple of days. Some very big names that you would recognize are customers of ours in their data centers. Well, they're not process manufacturers, but what do? They move a whole lot of cooling fluid to keep those processors cool. And they need to design and operate those things efficiently. And so we've got tools that assist in that space. So again, apologize that we got to collapse it just to make it understandable. But all of these businesses have been acquired. We're not opposed to building and borrowing partnerships, but all of these companies in general are 30 to 40-year-old companies, highly successful, large customer base, great people, great products that we're putting together in a portfolio to again try to achieve that thesis of being a leading provider of software to the process manufacturing space. So, one slide.
Yeah, I mean, actually, it's Dataco is a very interesting company. We've had the opportunity to talk to those guys over the years, and of course, we've worked with Chemstations here on the forum. But a lot of these are interesting software applications serving different needs, business and technical needs as well, not just business needs. And there's a real opportunity here to kind of bring them all together into an integrated software platform. And it's incredibly hard work, actually. It's not easy to find these offerings because a lot of them are small, relatively obscure, sorry, not Chemstations, but and then you're kind of bringing them together and then flanging them up. Yep. and trying to create a differentiated offering that kind of can serve the chemical industry in a more holistic fashion.
That's right. There's two ways we like to think about it internally. One is we're investing in all the products. We're making them better. We're looking for opportunities to have those products work together. So there's a huge investment in product management. I think you asked a question earlier, what does the market need, and how can we address that? That comes through our whole product management role. But the less generous way that sometimes we talk about it internally is customers want one throat to choke when something goes wrong, and we're offering you that one throat.
Data corpse.
That's right. I like it. I think we're going to be friends.
Well, as you can see, my expectations for this panel are working. So, Walt, why don't you tell us a little bit about GasTechno?
Is it the...
just the green.
Perfect. Okay, so I'm not one slide. It might be 8 or 9. So this slide here, the Aon did a study to look at the patent landscape for two-step processes, gas to liquid, that top box, and then direct or a single step patent landscape. And you can see the names, they're all who's who that have been investing in gas to liquids. And that top box on the far right there is really a global patent landscape for US and international patents. And in the bottom box, GasTechno sets itself aside for single step. So we basically are a very simple one-step process. Nexent, when I first got started in 2004, I hired them in 2006 to do a study to look at the competition, and they showed us in a study to be 70% lower capital cost, just because of that, removing that first step, which is a syngas process step. This is my commercial operations. I did a project in Michigan. We're a 20-year-old company. So think of us not as a startup, but 20 years in R&D. And for anybody out there, I don't recommend it. It's painful. This example in North Dakota highlights that. I moved my equipment out there in August of 17 and lived in a 50-foot Arctic skid shack for 7 months during a very brutal winter, and operated the equipment to demonstrate it for oil and gas companies, and left in March and swore an oath I'd never talk to another oil company. But here I am. One of the key differentiators that I've discovered in the last 20 years is to really make these technologies viable, you have to master manufacturing. So that would be counter typically to traditional models, which are EPC driven, project driven. And there's so much fat in these traditional EPC project models that we've decided to really take a reverse approach and go after the efficiencies of mass manufacturing. So even if it's a larger scale project, modularization and manufacturing is, I think, where the fat can be taken out of these projects and make them economic at smaller scales. So in Michigan, we acquired 36 acres, 10 buildings, and I finally was able to consolidate from about 4 different buildings into one building. And now I'm the mad scientist in my own little building. So it's worked out pretty good so far. We're a methanol producer. And so the idea was to utilize methanol as a low carbon feedstock. And that is a difficult value proposition for a lot of companies because there's so much fossil fuel methanol out there that getting into that, just taking small projects, putting it into a low carbon intensity score and putting it into regular methanol just doesn't make any sense for the big players that would be your off-taker. So we decided to pursue putting that methanol molecule into trucks. And in order to do that, we came up with an idea similar to like a Love's truck stop or a Flying J's, if you've heard of those. And what they basically have done is they've targeted Class 8 semi-truck owners and truck owners and used their energy center or their Love's truck stop to service, repair, maintain, and handle a lot of truck capacity, not just the fuel side, but actually the service center side. And that's unique to our model as well, so that if we're going to pursue methanol as a fuel, we really, and I got this from some of my Northern Michigan truck driver guys, friends that haul a lot of lumber, they haul a lot of materials with their semi-trucks. And my idea was, hey guys, if I convert your vehicle to run on methanol, which is low carbon, less emissions, would you be interested? And they're like, no. What's the price look like? And I said, well, the price is cheaper, but you have to modify your truck. And to do that, most companies are not interested to take on that responsibility. It's the same thing that happened with CNG trucks and a lot of the corporate fleet owners. They would do a propane conversion or a CNG conversion, and then they've got to service it. So they bring in the people to actually help. So they're building out their service network. This energy center would take care of that. So the fleet owner relies only upon us to do the service. This is an example of what we've already modeled. This is actually done by a third-party consulting firm. 5,500 gallons a day of methanol coming from my process. 50% in this case is sold to a Class 8 truck with a methanol conversion. The other 50% basically targets the methanol to hydrogen fuel cell market. And that's growing. Obviously, there's cost comparisons in terms of who's economic and who's not. And then we threw some numbers in there for the people that are looking for some basic metrics. And we came up with a cost per kilogram of hydrogen at the station of $4.44. And out in California, which is kind of where this model's built on, those hydrogen prices retail are 8 to 12. So there's a margin there. And what was most interesting to me is, fighting with the methanol customer, which would be like a Methanex or a BP or an off-taker. That $1,000 a ton price that you see there, that's a renewable energy, renewable methanol price. And the off-takers will, even though it's renewable based on landfill gas, they'd like to see it down around the 600 range. There's a lot of fat that they're taking, and it doesn't make it as economic for us at the field. You need to have those high methanol prices to produce methanol at a landfill. And so that $1,000 a ton is sort of a market driven right now. There's no subsidies in that. They're baked in, but they're not at my level. So $1,000 a ton methanol price puts it at $3 again. It's a beautiful price. So at the truck level, this is what the study looked at. They took a couple papers, industry papers, on EV trucks, and they did a study looking at the cost per mile basis. And when you compare the cost per mile to EV trucks and hydrogen fuel cells and diesel and CNG, and in our methanol, because even with that $1,000 a ton price, there's some efficiencies that you can get in the next slide. So methanol's low BTU makes it difficult to compete with. It's 56,000 BTUs, gasoline's 119, diesel can be 126. You don't have the BTUs, so you've got a lot. It takes twice as much fuel to go the same mile. Well, I looked at that problem, and from a, sort of an inventor, patent guy, I said, well, what happens if I took the powertrain of the truck and I got the efficiencies of the EV and put that in the powertrain? So it's sort of like a Prius. Think of an electric powertrain, gasoline engine, double miles per gallon. So I took the truck, designed a basic powertrain system for a Class 8 truck, and then the methanol, the diesel engines converted to run on methanol. So I get my 70-80% lower emissions coming out the tailpipe, and then I make up the efficiencies with that torque. And so it really is quite economic to do what I call the diamond package for what we're trying to do at the truck level. And so that gives you the background.
So we'll start with the tough question. $1,000 a metric ton, that's like twice of the average methanol price for the last, say, 10 years, right? Roughly $500, $600. It's been a while
Correct.
Since I looked at methanol prices.
Exactly, it is. And that's fossil fuel,
yeah.
Right? I think I just looked a couple days ago and it's up to the 600,
okay.
Fossil fuel. But if you look at Argus's methanol report, the $1,000 a ton demand and the pricing, which is market, is $1,000 to $1,200 a ton delivered to Amsterdam. So that market price is there. Now, I'm not trying to sell it to BP for $1,000. They're not going to pay it.
Yeah, but this is assuming RNG as a feedstock, or
yeah, landfill gas.
Yeah, so
correct.
Okay, so then conceptually you could take some LCFS credits if you sold it into California, and potentially offset some of that.
There's limitations right now on methanol.
Okay.
For LCFS and for RINs. It's undeveloped, right? So I was trying to, in the last administration, I was pleading with them to adopt methanol for California, LCFS, and submitted a couple, arguments, papers, and methanol doesn't have the same strength yet in terms of lobby, so there was not much success in that. So my numbers are based on not using any sort of LCFS or.
But if you were to use natural gas, say flared natural gas, right, which should relatively be cheaper than
a lot cheaper.
Then what kind of pricing do you get to?
Well,
what kind of cost do you get to?
So that was my first
GasTechno
15 years, exactly, 1.0, to try to prove that model up in North Dakota to the industry. Like, listen, it's a $10 million investment. I'm making your NGLs, because I got to take that fraction out. And then I want methane and ethane.
Yeah.
My process wants both, which is uncommon. Most want the methane, but in my case, my reactor allows for methane and ethane, and it gives me a good yield. So up in North Dakota, if it's a $10 million package and the flare tip is $50,000, it's like you offering a customer, hey, listen, here's my proposal for this, study. It's 10 grand, and the other guy says, well, I'll do it for 1,000. It's hard to compete.
Yeah.
And it's the same thing with what I was facing up in North Dakota. They're like, well, listen, congratulations on the technology. Looks really cool. Great, you're surviving up here in -30, -40 every day. But there's no, incentive for us to spend $10 million when a flare is 50 grand.
Yeah.
So that's what, that might change in the future.
Yeah.
But I'm back down to $500 a ton retail.
Yeah.
Methanol price, and that makes it even harder. So I'd prefer this. I think everybody likes to see renewables as a future pathway because it's really lower waste.
Yeah. So Steve, maybe we step back a little bit and talk a little bit about feedstocks in general, right? I mean, the chemical industry processes a wide range of feedstocks. How Chemstations supports a wide range of companies in the chemical industry, right? I mean, how does Chemstations help companies work with a broader range of feedstocks, I guess optimize the feedstock mix? Can you talk a little bit about what you see there?
I can, but I want to have a word with you first because you put me on a panel with a guy that has made me feel like I'm wasting my life. He's off designing new processes and new powertrains for trucks.
I do need that software though.
So to feedstock, what I would say is maybe I could tell a story to illustrate, and the one I'm going to tell is based on a true story, but just like when you see that in the movie, names have been changed
to protect the guilty.
Yes, yeah. So imagine a plant manager, Alice, and she's gotten a call from management team that has said, look. The commercial team says that some of our contracts for our feedstocks are coming up for renewal in about 12 months, and prices look like they're going to be higher. You need to do something. Go find a way to deal with this, right? And so she goes and visits with Bob. Bob is the tech support operations engineer for the distillation train, making their, we'll call it an intermediate specialty chemical product. And they start digging around to understand where the flexibility is. And Bob has a brilliant idea. Hey, let's call in Charlie. Charlie runs operations, and he's in charge of the advanced process control system. Let's take a look at it, because Bob's first inclination is, look, we can still sell as much of our product as we can put out. So we're worried about that margin. And a couple of ways to deal with that is you make more. They knew they were constrained, or you look for energy efficiencies. Can we use less energy making this stuff? So they pull in Charlie. Charlie pulls up the APC reports, and they see that there is a direct linear correlation between the energy they put into this distillation train and the product they're getting out. So they know they're constrained. There's nothing really that they can do. So they put in a call to we'll call her Deborah. So Deborah is the sort of roving project optimization expert. She comes in and looks at the process and says, okay, if you can unconstrain me on certain items, like where are we feeding these columns? How big are your heat exchangers? Maybe even adding a new column. Then I can run a process optimization on this. With the objective function being maximizing profit. I can put in the cost of our raw materials under this new contract that's coming out in a year, and I can put in the fact that we want to just maximize the output of this thing, and I can let it rip, and you get some cool results. It's like playing a video game. And so in this particular story, they came up with a reasonable alternative. We can replumb where this column is fed, and we can actually increase the size of the heat exchanger at the bottom. And so that does two things. It made it more energy efficient to move the feed. It was badly designed to start with. And then having a larger heat exchanger allowed them to take advantage of that linear correlation between energy input and throughput. So at the next turnaround, Alice has gotten full approval to spend the money on that small project. They ran out and did project engineering internally because it was small. And at the next turnaround, they executed on it. Nice big heat exchanger down at the bottom, and replumbed the feed location. For about a year and a half, everything was great, exactly as they determined. Now, what happened a year and a half later, we got called back in just to catch up with them on a quarterly business review. It turns out that the market for their product softened, and what they normally would do is just scale back production. Because they had increased the size of that heat exchanger, as soon as they scaled back production, they lost control of the process. They can't, the heat exchange, the heat transfer effectively disappeared. So they had to make a tough choice. Do we just sell it below market, eat the margin, or do we store it? And so as we're talking to this customer, it is exactly this situation you're describing, Uday, is they had the tools to deal with the situation. What we try to talk to our customers about is you have the tools to analyze all these situations in advance. Most of our customers, I would say, do not use this enough, and I'm sure I could put that on our competitors in the back of the room. Would say similar, that you're not using these tools enough. If you are in the space, you can run models. They run fast. Computing is cheap these days. You can run massive optimizations. You can give these things control of every variable in your process. And if they had just modeled out all of the various business scenarios in advance, they could have seen this coming and could at least have had some contingency plans. And so I use this as an illustration when I'm talking to customers, when they're sort of asking what's best in class use of simulation these days. And it doesn't need to be a full digital twin dynamic simulation. This can be just a massive series of steady state simulations. You can do a lot, and you can increase your understanding of your current processes and do a lot of planning for contingencies, whether it's feedstocks or what you can sell your product on the market for. So,
but Steve, are there limitations on the kinds of feedstocks that your products can help with? Like, because there's a wide diversity of feedstocks that's now feeding into the industry. It's not just hydrocarbons. There's like bio-based feedstocks. There's recycled and pyrolysis oils, right? I mean,
yeah. So I would say we are not limited. If these are well-studied molecules, they're going to be in all the major simulators. Are going to have them in the database. If it's something super unique, some quick lab analysis will get them into any simulator. So there's no limitation there, and that actually furthers the point of, hey, either it's a surprise and you've got a new feedstock and you've got to do an assay and quickly get a simulation built, or you can sort of survey the marketplace for your different feedstocks and what's available, and use simulation to decide which one is going to help your process the most. Which one gives you the best results, because it may be that the cheapest one is not the right one because it's got some impurity or it interacts badly with something else in the process. You can capture that long before you make the commercial decision to buy it. So yeah, I would say, the bottom line is almost every chemical company of any size or significance has access to these tools today, and they're just not using them in this way until they sort of are in the thick of the problem. And we try to argue do this earlier. Have really good models of your process kept up to date. Something changes in the plant, make sure somebody's in charge of updating your simulation to match changes that are occurring on a month-to-month basis. And then these things don't become such a economic impact to your business.
Yeah. So, Walt, methanol has a wide range of chemical applications. The challenge, though, of course, is that most of them rely on fairly commoditized. They're viewed as a commodity, right? And one of the challenges of your technology is that costs could potentially be higher, right? But are there applications that you see in the chemical industry, for example, for your technology?
This conference has opened up my eyes with opportunities for chemical pathways, and so I think renewable methanol at sort of small scale is not going to get into the BASFs, the Dows, the big companies, because it's just too small of an impact. But specialty chemical manufacturers, smaller scale, like formaldehyde. I had a call with trying to think of the name of the formaldehyde producer, but they're big, and they suggested their processes allow you to make 5% formaldehyde, 20%, 25, 37, 45, 50%, and they're almost they're custom, like we learned today. That custom manufacturing for chemicals has got a very good value proposition for strong margins if you can. So that's, formaldehyde, acetic acid, but at smaller scale. I think that scares people away because they're looking for economies of scale and large scale projects. But I think, as I mentioned to you before, the manufacturing is where, as far as I'm concerned, my focus right now is manufacturing, because that's where I know I can keep my costs down. If I get into manufacturing, mass manufacturing, and not necessarily building a jumbo plant, like Tesla, but just mass manufacturing of trying to pump out plants. So that's where I can keep my cost per gallon low and not compete with the economies of scale of the Chinese projects.
Well, let me open this up to questions from the audience, see if there are any questions that the audience might have.
Yeah, thanks. Question for you, Walter. What's the size? How much gas can you process in your modular system?
So the one that is in construction right now is what we call our Mini GTL 750 unit. And it's sort of optimized for 750,000 standard cubic feet of gas. And then in terms of, what we see in the landfills, that 1,500 SCFM raw gas is sort of an untouched, landfill gas size out there, where everybody's after the bigger 3,000, 5,000, 6,000, giant economies of scale. But that 1,500, and by the time we clean it up and get that into a pure methane stream, if you will, it's basically an LNG stream, it works perfect with the 750. So we're just gonna stay right there at that. A package system, turnkey. We are not gonna go bigger or smaller. Our focus is just, this is what we sell. That's the only size we sell. And then maybe, 4 or 5 years from now, we can say, oh yeah, we can expand up or down.
And the 750 is the raw RNG that has CO2 in it, or is it you clean out
That would be methane. 750,000 cubic feet a day inlet of methane.
More questions?
I think they're all asleep.
Yeah.
So yeah, Patrick.
For Walter, what are the challenges you are facing when you are reaching out to customer with your new modular?
I think the main metric is 1,000 hours of continuous runtime. That's sort of the industry metric. And we've got about 750 hours of runtime by doing the pilot, seeing that was successful. Then we moved to a demonstration scale unit. We got that successful. We got the larger scale reactor dialed in. Then we went to the commercial unit. We got that dialed in. And so it's sort of an industry standard. And he mentioned it this morning. As long as you've got 1,000 hours of continuous runtime, we're open to talk to you. So I'm not so worried about, because I understand the reaction, I understand the equipment, the system, and how it runs. I'm not so much worried about that runtime. And so to avoid the pushback from industry, we've just decided to sort of come up with a solution to, take it right past the industry players and go to the truck owners and say, hey, listen, we'll take all the risk on the backside. You don't have to worry about methanol production. That's our risk. You guys worry about, bringing us your truck to the energy center for, conversion, low cost fuel, et cetera, et cetera.
Last call for questions.
So, Steve, my question is for you. How do you see your customers asking about AI, and what are your plans trying to incorporate some of the machine learning AI into your offerings?
Got it right in under the wire, right? The AI question. So we think about that in a lot of ways, and I think I will echo what Anahita said earlier, because I think it maps onto what I said last year about it, is that if you're going to use AI directly on process models and actual operating conditions, you need to be very careful. Anahita called them guardrails. An AI does not necessarily know anything about physics, and in our industry, if you get things wrong, stuff blows up, stuff breaks, people die. So we when we talk to our customers about it, and when they're asking what the play is, we're very careful. Additionally, because we actually are part of a larger group with DataCore that is very data intensive, ERP, CRM, there's a lot of text and numerical data that they look at. It doesn't have that constraint. There is a burgeoning AI group within DataCore that is looking at leveraging all of that data to train models and be able to help our customers make better decisions. On the process side, what we've looked to do is partner. So we gave a paper at ACMA last year with a group that has a lot of AI and machine learning experience, and they're all chemical engineers, and they understand those guardrails very well. And the idea is to improve operations. We're working with a group out of Austin, Texas now, a startup that has chemical engineering backgrounds that are focused on process optimization using AI. And so our view is that we are willing to work with experts in AI when they have that sort of fundamental chemical engineering background when it comes to process models and process operations data. But beyond that, what's just some interesting experiments we've been doing over the last few years, if you go on to Grok or OpenAI or ChatGPT, any of the major LLMs, and you ask it questions, and I'm sure you can do it with our competitor software too, but you can ask it questions about how to deal with a problem with a process model. Hey, my ChemCAD model isn't converging. What should I do? It gives, over the last couple of years, those answers have gotten really good and really interesting. And so there are ways to play AI to improve the customer experience, the user experience as you're using our software. Certainly, we want you to call us, and we've got experts waiting and love to help and dive into a challenge with you. But AI is going to be a part of that going forward, because it might be 12:30 at night, and you've got to get something done before the next morning. You may need an answer right now. AI may eventually be a part of that process. So a lot of different applications within our space, and we're lucky enough again to have a pretty good AI team within the company to lean on. So.
Excellent, thank you. We are at time, but Steve's available. So Steve, there's one more question for you. So we'll probably let it after. Okay. Maybe offline, sure. Because we want to get to our keynote here. With that, let's give Steve and Walter a hand here, please.